right, so now we're going to graph a line that's parallel to the line y equals 4x minus 5, passes through the point negative 4, 2. So we're going to be graphing linear equations in this lesson in point-slope form. To graph them in point-slope form, we're going to first graph our given point. Right, so we are given the point 4, negative 2. Let's graph that point. Right, so, excuse me, negative 4, 2. So negative 4, 2 is right here. Right, that's our point that we're given. Right? So now we're going to use the slope and count out more points. So from our given point, we're going to use the slope to count out more points. All right, so now let's find our slope from the equation of line that we're given. All right, we know that the slope is that coefficient right in front of x. Right? So we have a slope of negative 4, which means that the rise is negative 4 and the run, that word is run, it looks like none. Is 1. I'm going to move that where I underlined. It's kind of in the way, isn't it? I'm going to write it like this. There we go. Or we could say that the rise was positive 4 and the run is negative 1. We can count down and to the right or up and to the left. Well, we pretty much have no space. Well, we could count a little bit up and to the left. Count once anyway. That will be about it. So let's count down and to the right, and then we'll count up and to the left. All right, so we'll count down 1, 2, 3, 4, and to the left 1, 1, 2, 3, 4, and to the left 1. We could also count up 1, 2, 3, 4, but then we'll go to the left. All right, and you can see our points are all on the same line. All right, so now let's connect those points. All right, so if we want to write the equation of the line, notice, well, if we want to write it in slope-intercept form, right, we don't know what the y-intercept is. We know what the slope is, but we don't know the y-intercept. Notice my graph never crosses the y-axis. So if the y-intercept is not known, we can use point-slope to write the equation. Right? Because we have a point, we have the slope. Right? So we have y, and so here's our x and our y. I'm going to write the equation, the form. So y minus y1. Right, so the y stays, the y1 is replaced with the y coordinate of a point, equals m, we got to replace that with the slope, x stays, and then minus the x coordinate of our point. So we have y minus 2 equals, our slope is negative 4, and then x minus a negative 4. Of course, that's going to simplify. Simplify that double negative there. Y minus 2 equals negative 4 times x plus 4. Next, so now we want to isolate y. If we want to put it into slope-intercept form, what we have right here, that's point-slope form. And if you're just asked to write an equation of the line and nothing is specified, we could write our equation in point-slope form. Why does that look like point-slope? Let's make a better looking L. But sometimes you're going to be asked, especially in this class, to write it also in slope-intercept form. So to do that, we have to isolate y. That means we need to distribute that negative 4. So we have y minus 2 equals negative 4x. Negative 4 times 4, that would be a negative 16. And then we just have to add 2. Oops, I did not mean to hit the extended page, but I think it's still not too small. We'll add 2 to both sides. All right, and so our equation is going to be y is equal to negative 4x minus 14. I don't even know what happened to the 2 over here. or that minus 2, but plus 2. There we go. It just disappeared. All right, so here's our equation in slope-intercept form. If I didn't write so big, I'd have plenty of room. Just for comparison, let's see what the graph of the parallel line looked like. All right, so we have y-intercept of -5, and then a slope of -4. We're not going to be able to count down and to the right, so we'll definitely have to count up 1, 2, 3, 4, and to the left. 1, 2, 3, 4, and to the left. 1, 2, 3, 4, and to the left. And now when you look at those, you can see, because we have points right there, that those two lines definitely have the same slope. They have the exact same rise and run all the way through. We can see they're going down 4 and to the right 1. So on the right-hand side is the graph equation we were given, y equals -4x minus 5. On the left-hand side is y equals -4x minus 14. Right? So point slope form will come in handy when you don't want to extend your graph all the way to -14 to find out what the equation was. Right? And so all we have to do is graph what point we're given, and we'll count up more slopes. Sometimes you'll know the y-intercept right from your graph, and you'll be able to write the equation in slope-intercept form. If your y-intercept is not known, you can use point slope. Sometimes we'll leave it in point slope, and sometimes we'll simplify it. Just for practice, in this lesson, we'll just always simplify it. All right, let's do a few more examples. All right, so we want to graph a line that is parallel to the line y equals -4, and that passes through 0, -6. Well, in this case, we do know our y-intercept. Right, so it's the point 0, -6. Sometimes there are b here, and our equation would be a -6. But what is our slope? Y equals -4. Well, maybe we could graph that. All right, so we got a y-intercept. Oops, I hit the graph there. I hit it over here. We have a y-intercept here at -4. What kind of slope does this line have? Well, you know, another way I could write that line is y is equal to, there's no x there. So if there's no x, there must be 0x minus 4. So there's our equation in slope-intercept form of the one that we're given. If it has no slope, or I should say, excuse me, if it has 0 slope, so I don't like to use the words no, because no and 0, just, you know, if you have no money, then you have 0 cents, right? So let's just say 0 slope and undefined slope to distinguish between those. All right, so here we have 0 slope, and here is our line, y equals -4, which is the same as y equals 0x minus 4. So what is it? We now know our slope. What's our line going to look like? Well, it's going to be a horizontal line. Our slope is going to be 0. So our y-intercept here is at 0, -6, and we have a slope at 0. We're going to be a horizontal line. So I tried to graph this without a line tool, and you can see why I need a line tool and why you should use a ruler. However, I did want them to stand out against the black coordinate plane. So here we have y equals -6. And there that we are. All right? So if there's no x, and you have y equals a constant, remember, y equals a constant is always a horizontal line. Your line parallel will also have 0 slope and will also be a horizontal line going through whatever point you're given. We could still graph this even if we weren't given the y-intercept. So for instance, what if they said it was going through the point 5, -6? All right, well, here's the point 5, -6, and it's still going to be a horizontal line. Right? And it's still going to be the equation y equals, oh, I should probably write the equation down, y equals -6. I don't think I did. So here our equation for this graph, oh, I did write it on the graph, but I'll write it over here too, is y equals -6. Right? That was a nice easy one. Yeah, I like those horizontal lines. Right, so sometimes it is easier to graph equations in point-slope form, and we would not want to change it into slope-intercept form first and then try to graph it. I think it's always easier to graph it in point-slope form, because if you're not asked to write the equation of the line in slope-intercept form, you can just use point-slope. There's no work really in that. You just got to plug in some numbers. If you are asked to write the equation in slope-intercept form, maybe you can find your y-intercept when you graph it. So, but this one is definitely going to be easier to graph in point-slope. All right, so first step is going to be to graph our point, which is 1, 2. We're given a point. So 1, 2 is there. Okay. Second step, we're going to identify the slope. And to count out more points. Right, so right here's our slope. Right, so our slope is equal to 1/3. Right, so that means our rise is 1 and our run is 3. Or that means we go up and to the right, or we can go down and to the left. Right, and we can do both. We have enough space. All right, so we're going to go, let's go down, or go up and to the right, and then we'll go down to the left. All right, so rise is up 1, and then to the right 3, up 1, to the right 3. We can go down 1 to left, down 1 to left, and that's it. And then we run out of space. And so now we'll graph that by connecting oops, there we go. There we go. All right, so can we write the equation in y in slope-intercept form? Well, it crosses, we can see where it crosses the y-axis, but we would have to guess what this point is right there, right? I don't know what that point is. It's not an integer, right? So we're always going to, if we want to write the equation of the line, use point slope to write the equation of a line. Come on, rest of my words. If the y-intercept is not an integer. So that does not equal an integer. Right? We don't want to guess what it is. We don't want to say, it's approximately this. No, we need to have exact. Right? There's no rounding here. We want exact numbers. Right? So let's use point slope. Right? We've got a point. Right? We know the slope. Right? So, and I'll write the formula again. Y minus y1 equals m times x minus x1. So we'll have y minus 2 and 1/3 x minus 1. So there's our equation in point slope form. And so if we simplify it, we'll have slope intercept form. So that would be, we'll just distribute the 1/3. Y minus 2 equals 1/3 x minus 1/3. Now to be able, I don't want to see mixed numbers, to be able to combine fractions, and so 2 is technically a fraction, it's 2 over 1. Right, we need to have a common denominator. And our our denominator is 3, right? That's the only it's the only denominator there that's other than a 1. And so I need to change 2 so that it still has a value of 2, but it has a denominator of 3. Well, my denominator is 3 times as much. Your numerator has to be 3 times as much as well, right? So 2 times 3 would give you 6, and 1 times 3 would give you 3. So 6/3. Let's replace that 2 with the 6/3. Y minus 6/3 equals 1/3. Oops, what happened to my x? X minus 1/3. And so now we'll add 6/3 to both sides. Y equals 1/3 x. A negative 1/3 and a positive 6/3 is 5/3. Right? And there's our equation in slope-intercept form. Do not change that to a decimal because that decimal is an approximation. And like I said, I want an exact answer. Right? Sometimes decimals, they take off too much. Right? We want the exact answer. And there's no reason we can't have the exact answer. Right? And so there's our equation. So you can see sometimes it's much easier to graph in point slope form. The last thing we'd want to do is write the equation in slope intercept form, then go and try and graph it. Okay, now where's 5/3? Okay, now I've got to count a third from that? No. Graph 1, 2, and it was easy, right? Here's the point 1, 2. Use that. Don't try to use 5/3. Right? If we need the equation, we'll find it later on. Right? But we're not going to try and graph it or using that equation. Right? Much easier in point slope. And really, it's just as easy in point slope as the easiest slope intercept form because I'm just graphing a point. Who cares if it's on the y-axis or someplace else? And just counting. Right, so we're going to graph a line that's parallel to 2y equals 4x minus 6, passes through -2, -4. Right? So sometimes we can write the equation directly in a slope-intercept form. And then it really doesn't matter. Right? And then you can do it that way. I'm going to do it for this one only just because we could graph it in slope-intercept form. Right? But otherwise, I would just have graphed point -2, -4. But I'm going to actually graph that to show you that -2, -4 will be right on our line. First thing we do need to find, though, is our slope because our line is not in slope-intercept form, the line that we're given. And to do that, we're going to have to divide everything by 2. So we have y is equal to 2x minus 3. Right, now we know our slope. Right, so let's just use point slope and write the equation in slope-intercept form on this one. Right, so y minus y1 equals m times x minus x1. And there's our x1 and our y1. So we have y minus a -4 equals 2 times x minus a -2. Should really have another parentheses in there. All right, so that would be y plus 4. And then I have equals 2x, or excuse me, I don't want to distribute yet. 2 times, this would be x plus 2. And so now we'll distribute the 2. Y plus 4 equals 2x plus 4. And then we'll subtract 4 from both sides. So now y is equal to 2x. Well, that's a pretty easy equation to graph, right? And it's about the same, though, as graphing the point and then using the slope. So y equals 2x is going to have a y-intercept, of course. That's 0, 0. So right here is our y-intercept. Right? And so we can use the slope to count more points. Right? If our slope is 2, that means our rise is 2, and the run is 1, or it means they're both negative. Right? We're going to count up and to the right or down and to the left. Right? So let's count up and to the right. So 1, 2 to the up 2 to the right 1, up 2 to the right 1, up 2 to the right 1. Now I can go down 2 to the left, and notice there's our point. -2, -4, right on our line. Right? So if we didn't want to find the equation in slope-intercept form first, we could just count right from that point that we're given. And it's just the same thing. Right? And so now we will graph our line. Ooh, there it goes. Come on, woo, move over. So I've been graphing the lines that we've been given in the rest of these. Maybe I'll do it on this one. We haven't done it in a while. Oh, I did on the horizontal lines, but maybe I'll do it on this one as well. And I think I want another color so it looks different. So the black line here with the blue dots, this is y equals 2x. Y equals 2x minus 3. It's the same slope. It just has a y-intercept of 3. It's like the same line, just moved up 3 spaces. And it would still have a slope of 2. Oh, excuse me. That was negative 3. Woo. So that means it's down here instead. Same idea. Just move it down 3 instead of up 3. And now have my points gotten offline. All right, you go here, and you're supposed to be here. Okay, now we can count. All right, so up to the right 1, up to the right, up 2 to the right, up 2 to the right, up 2 to the right, or down 2 to the left and down 2 to the left. And I'm going to try to graph in any other color but black. How about green? It's like a sickly green. Well, we'll think of it like it's like a plant green, if the plant has been dying. All right, and so here we have y equals 2x minus 3. And you can see we have parallel lines because they have the exact same slope. You can see those points, right, having the exact same rise and run all the way through. I think I've got maybe one more. I think this one's it. So now notice we're not even given a line at all. Right? We're given some points. We want to graph a line that contains -1, -4, parallel to line FG, with F at -2, 3, and G at 0, 2. Right? So this is our point, right, that we're given. This is our point. If we're graphing the line that contains that point, graph this point, don't use the other points, unless you want to just graph both of the lines together, right, and see what they look like. All right, now we need the slope. To find the slope, we have to find the slope of FG, that line, right? We're not going to use A, because A is not on FG, right? I'll even put that in. Use points from line FG. Not point A, right, to find slope. Right, so you be the second point, oops, and you be the first point. Right, so our slope is going to be 3, I didn't write the formula, I probably should. Remember the difference in the y coordinates divided by the difference in our x coordinates, just to remind you. All right, so that's going to be 3 minus 2 divided by, so I started with 3, I got to start with -2 minus 0. So 3 minus 2, that's 1, -2 minus 0, that's -2. So we have a slope of -2. Right? And we have a point. If I'm not asked to write the equation of a line, then all I have to do is graph the point. -1, 1, 2, 3, 4. Oops, -4. I seem to start graphing, then look back at the point to realize what the coordinate is. -1, -4. And we have a slope of -1/2, which means we'll go, our rise is -1, and the run is 2, or the rise is 1 and the run is -2. So we can count down 1 to the right, down 1 to the right until we run out of space. Or we can count up 1 to the left, up 1 to the left, up 1 to the left. Can I use these lines? I don't know why there are these little lines over here. But can I, yeah, I can graph with it. Ooh, there we go. I'll just take these little lines. I have no memory of why they were up here, but look how cute they are. Oops. There we go. Right, so there we have our line graphed. Right, there our point that we were given was right here at -1, -4. Right, and we have a slope of -1/2. The other line would go through 0, 2. Right, so actually the line that we were given, since we know we have 0, 2, and we have -2, +3, we can see our line that we were given really easy, right? So here, whoops, we have to get the dots first. All right, so I didn't graph any more points, but I can make sure it goes through at 1/2 by making sure I go up 1 and to the right, or left 2, or down 1 and to the right. All right, so this one is pretty easy. This one was the line FG. And that's the equation y is equal to -1/2 x minus, plus 2. Right, because we're given the y-intercept on that one. And we calculated out the slope. If we wanted to find the equation of our line, right, so that's FG. This is our new line that contains A. Right here is A. We would have to use point slope, right, because it's not clear what that point is. So let's just do that real quickly, and that will end this podcast. Ooh, it's a little longer than I planned. But we're going to have to use the point -1, -4. So y minus a -4 is equal to -1/2 x minus a -1. Right, simplify the negatives. Y plus 4 equals -1/2 x plus 1. We'll distribute. Y plus 4 equals -1/2 minus 1/2. And so 4 is the same as 8/2. Right? We just multiply both of those by 2. So we've got, I'm going to just write, now let's write y plus 8/2 equals -1/2 x minus 1/2. And now we're going to have to subtract, I'll give this small, 8/2 from both sides. So that means our equation, I'm going to put it over here, is y is equal to -1/2 x minus 9/2. So this is the line that has point A in it. In slope-intercept form. And then line FG, that was the line y is equal to -1/2 x plus 2. Make sure you don't get them mixed up, your points, when you have you're given points for two different lines. I do think that's it for this one. This one was just a little bit longer, but your whiteboard practice is not that long. Right? So has some information for you, and you'll be able to see that on the website. And actually, I might be changing that, so don't look at those questions. So pretend you didn't see them. But there'll be a whiteboard practice, because I actually think I'm changing one of the questions. So don't use those. Use the ones on Schoology. All right, bye for now.